Hello class, welcome to Big Bang Data Science Solutions, the Ramadan free program in exchange for $150 donation to any church, any mosque, any family need. Thank you so much for being part of this program, and thank you for those who donated. Thank you so much for donating to whatever cause you are. Doesn't really matter to us. Either you are Muslim, a Christian, a Jewish, we really don't care. All what we care about is give, and we will give you. Give, and you are going to receive. That is even what the Bible says. Give, then you will receive. Right. So please share the program with churches, with mosques, with people who want to learn, and simply we can train them in exchange for helping others. We've been doing these programs. We've been offering this program since 20, I believe, 18 or 19. I don't remember exactly. And so far, we have raised over probably 150,000 that went all in donations. Okay, so in week number one, we talked about why you should become a data scientist. So if you missed this session, please go through it. It is very important. It does enlighten you, help you understand why you are here, and help you understand why you are continuing taking these sessions with us. This really is going to answer. It does answer a lot of concerns, a lot of questions that you might already have, and you did not have a chance to ask because probably you missed it. So please go through this lecture one more time. It does address most of the questions that you have. So in week number two, we learned about the first phase of one methodology used in the domain, and that is CRISP-DM. So we learned about business understanding, or business analytics and business understanding. Week number two. Week number three, we had a crash course on Python, because the Python is going to be the language we'll be using throughout the program. So we had one crash course in Python. And then we moved in week number four, which is phase number two, data understanding, explore data analysis. It's simply trying to understand what we have in this data. Now, how is our data from the inside? How is the quality of this data? Is it good or bad? Is this something that we can rely on and move on, or do we need to work out our data, make it ready, prepare it for the analysis? Then in week number five, we learned about data preparation. So after we understand what we have in the data, after we understand how is our data from the inside, then definitely we need to we are supposed to come up with a plan of what we have and what we need. So we have, for example, a column that says age, and this age is not normally distributed. Then we need a normally distributed age. So we have to transform it from non-normally distributed to normally distributed feature. We have, for example, a column that is male and female, gender male and female. It's categorical, but we still need the gender, but we don't need it. We need it in different format. We need it in zeros and ones. We need it in numeric. So we have to transform it. So how do we know what to transform? We have to spend time understanding how is our data from the inside. And this is very, very important. Otherwise, you won't be able to understand what you're supposed to do in terms of preparing your data for analysis. So we spent 2 weeks, data preparation part one and data preparation part two, and we are supposed to do week number six, which is supervised learning. But let me go through. We are going to do very quick data preparation one more time, and if we have time, then we are going to talk about machine learning. Okay, so we got the data. As you see here, we got the data, and as we talked about, as we discussed yesterday, The first thing to do as data scientist, wherever when you have something, this is the first time you are having access to your data. So and imagine that you have 10 millions of records and you got 500-600 columns. That is a huge data set that probably your system or my system wouldn't be able to handle. So what we could do as data scientists is we are going to use the Excel. You are allowed to do that. Simply go through these columns, at least the columns, and try to determine if which feature should not be making it in the first round. And yesterday we learned about prior knowledge, and in prior knowledge we learned that all IDs should be removed, all personal information should be removed right on the fly. You don't have to read the data first, just remove it. All the high cardinal or high not cardinal, high granular or the features with high granularity should be removed. And if you have features with the same information, providing the same information but a different level of details like zip code, location, address, state, region, they are providing the same information but different level of details. We are going to keep only one. So eliminate everything else except only one, and most likely we keep the one with less details and less hierarchies or less cardinals. Then we learn to remove dates, unless you are planning to use time series analysis. We learned about leaving out or removing anything that is constant. If you have a column called age, and in that column you got the same number all across your 10 million records, just remove it. So this practice, as I said, is called prior knowledge. So feature selections using prior knowledge. And now we are going to read the data. Yeah, we are going to read the data. And once we read the data, then we are going to apply other methodologies or other scientific methods to remove extra features. Okay, so we were here yesterday. So we imported the libraries. Yeah, let's do it again. Then I'm gonna start the kernel. And I love to start fresh. Can you guys see the font? Or do you want me to increase them?
It's fine.
Fine. Others?
I see it. It's good.
Okay,
A
good.
little bit larger for me, Mohammed.
Unfortunately.
Okay, no problem.
Yeah, I mean, I can, but how about now? This is too small. It's too small for me. Yeah.
Smaller than before.
Yeah, let's make it 125.
Okay, that's better. Yeah.
Yeah, so we are going to import the libraries and modules, NumPy, Matplotlib, Pandas, Seaborn. Then we are going to maximize the number of columns we want to explore or want to see. And we are going to read our data. Okay. Policy number. Yeah, there is a, yeah. So when you read the data, the first thing that I would do is simply go through the column names, customer as a month as a customer, age, policy number, policy bin date. As you see, they are not constant. We got age is capital. Everything is a lowercase. Age is an uppercase. We got policy. There is a space in there. Policy number, and we got exclamation mark. So what we could do, just to avoid having problems later in the program, is we want to make everything consistent. So we could do that using one library. It's called PyGenerator. Yeah, this is PyGenerator. Yeah, let me see PyGenerator. And now I have the codes, but simply couldn't. So let's do this PyGenerator. Okay, there are three ways to install a package. Yeah. Number one, we could do it through the Anaconda itself. We need to use exclamation mark, pip install PyGenerator, or we are gonna do we are gonna go to home directory, go to new, click on terminal, and do pip install, or we are gonna do it through the command prompt. Command prompt is very fast, so let's do it through the command prompt, and it's gonna say our requirement has been satisfied. There we go. Great. And now I'm going to copy this one line. It says here, this is one line. Okay, and we are going to modify it. So we got this. I'm going to comment it out. I don't need it anymore. Okay, and I'm going to do, we are going to override, and it's going to be so we are going to use clean, and we don't need the empty, only the names, clean names. Data frame, clean names. The F, okay. Company sales. Okay, so we installed the library already. And so before we do that, let's print out the column names so we can compare them. So this is what we have. As of now, we got month as a customer. We get age is capital, all uppercases. Policy number, and we got a space in there. We got another space, and we got exclamation mark. Everything else looks good, but I did it in purpose. We don't have it in the data, but just in case you have this type of problems from the early beginning, one way to handle it is using the generator. And generator library, it comes with it supports R and Python as well. So we installed the generator, we import it to the memory, and now we are going to use it using the same codes provided to us. Simply copy paste, and you DF stands for data frame. It's your data, and use the same same code, and simply change the name of your data. Now you need to change the name of your data, and you should be good to go. So now I'm going to run this and watch what's going to happen. Import, you got two imports, and I got two imports in there. Here we go. And now it's you see it went through all the 39 features. And now let's compare what we have. So we get age, and now it's age, all uppercase, lowercase, uppercase. We got policy number, exclamation mark. We got a space in there, and the spaces have been transform into underscore. Everything is underscore. So in the data that was provided to us, there was a lot of spaces in there. Month as a customer is a space, and a lot of uppercase, exclamation mark, the special characters. And this might create problems in the future. So just get rid of them by cleaning your data right after you read the data. Okay, we talked about the head, the shape, the info. We talked about the target variable. And we talked about that we visualize our target variable. This is what we have. Then we talked about transformation. So now we are going to learn about, then we talked about data analysis. So using data visualization. So now we are going to take a look what we have. So this is what we have. So we talked about the, yesterday we talked about the correlation analysis, another method of eliminating or applying dimensionality reduction. We already applied the prior knowledge, and we were able to eliminate 6 features, and we did the correlation analysis. We eliminate, I think, 4 or 5 other features. And now, if we look into this data, we got some problems. Number one, we got categorical data. We got categorical data. Here we go. And we got some question marks in there. So before we make a decision on these question marks, as data scientists, so number one, we have to talk to our team. And you remember, in your team, you have at least 3 expertise. You have a data expert and you have a domain expert. Talk to them before you make any stupid decision. I know you are going to think, should we probably remove them or replace them? There are many ways to do it. But just to be on the safe side, talk to someone who knows data better than you and find out, why do we have a question mark? What this question mark signifies? Does it represent unknown? I don't know. Or is it missing values, or is it a real value? So find out from the business. Then based on what you know, you make your decision. Don't make a decision just because you know what to do. Now you know what to do, yes, but you don't know your data. So you need to talk to a data expert. We should be a member of your team and try to clarify these concerns. Okay.
Assalamu alaikum.
Walaikum assalam wa rahmatullah. Are you talking to me? Okay. So let's. So now, so we have all the visualizing, trying to visualize all the features, or all the features with the question mark. So we got collision type. It has question marks. We got also question marks. We got property damage, has some question marks in there. And we got police report, some question marks. So one way, let's assume that we know that through our expert that this is a missing values. So we find out this question mark is missing value. We don't know. So when we are handling missing values, there are many ways. There are many ways to deal with missing values. Number one, simply delete. Sorry, guys. Number one is simply delete. Yeah, please, Muhammad Attar, everybody, please mute yourself. So number one, we could simply delete them. Bye bye, bye bye, bye bye. But there is a problem. If we were to delete, before we delete them, we need to find out how many. How many of them? Why do we know how many of them? Is because delete, if we have 50%, and if you were to apply delete, then you are removing 50% of your data. So you are short by 50%, and that's not practical. You could have lost a lot of information in that 50% that you just deleted. So, but delete is one option. Second is called impute. Impute. What is impute? Impute is replacing the missing values either with the mean, with the mode, and with the median, and sometimes with the standard deviation or variance. Okay, so when do we replace with the mean? If we have numeric. So is this numeric? No, it's not. It's categorical. So mean numeric is not going to work. Median is not going to work because this is applies only for numeric, and the standard deviation or variance is for numeric also. So it's not going to work. The one left is mode. This is for categorical. So what is impute with the mode? We are going to try to find for example, for this one, we are going to try to find that which level is more frequent. Is it front collision or rear collision and side collision? And we need to replace the question mark with the most frequent. But there is going to be a problem in there, and here is the problem. So for example, for this, we got collision type, we got policy report. This is collision type. We got policy report, and we got property report. And let's take a look into the values. The question mark, for the auto insurance collision, we got 29% rear, 27 side, 25 front, and 17 is question mark. So we need to replace question mark with the most frequent level or category. So what would be, question to you all, what would be the level or the category that we need to replace the question mark to?
Rear collision.
Rear collision. Anyone?
That's the most frequent.
Anyone?
Not sure because they're all very close, like 29, 27.
Then why do you need to do?
Side collision?
Unfortunately, none of them is because if we were to add 17% to 29, for example, then you are going to have a bias. So the only time that we can do imputation if we have few missing. But now we got 17% is missing for this column. For this question mark, we got 34% is missing. We got for this one 36%. So you see the question mark for the property damage is the highest, is the most frequent. Policy report is the most frequent. And we got a higher percent now. We got another higher percentage for the other column. So Imputation, if we were to put, transform or change this the category with this question mark with the most frequent, then we are going to have one very, very large category and one is very, very small, and we are creating a bias. So we are creating a bias, and if you have a biased model, then the result is going to be biased. If you have a biased data, the result is going to be biased. And if you have a biased result, of course, whatever decision you are going to make or you are going to take is going to be biased. So then what would be the solution in this case is we are going to keep it. We are going to keep this question mark, but we are going to change their question mark to something meaningful. So we are going to replace them with an unknown. Unknown. So we are going to replace the question mark with an unknown. So we know it's unknown. And to do that, we are going to use replace function. So please take my data, the data that is auto insurance, and this auto insurance 1,000 features, means 1,000 records and 39 features. And please take this data and override it with the same data, but please go ahead and look for question marks anywhere and replace it to an unknown. Let's do that. And we are going to repeat the process again. Let's take a look into that. Now, if I were to run this one more time, you are not going to see question marks anymore. You are going to see unknown. There we go. We got an unknown. We got unknown, unknown. We got side collision, rear collisions, front, and unknown. We don't know. Yes, no, we don't know. Yes, we don't know, and no. So we cannot apply any of these techniques. Delete, impute. Number 3, we don't need to impute. We don't need to delete. We are going to keep them, but we are going to use a robust machine learning models later. And many machine learners can handle data with missing values. Decision tree, one of them. We are going to learn that later. Random forest, bagging, boosting, AdaBoost, gradient boosting, all of the models that they are built on decision tree. Number 4, we could build a model to determine what would be the value of these question marks. Okay, so we are going to use this as a target variable, collision type as a target variable. We are going to build a model, and question mark is going to be, we are going to separate the data into 2 parts. One part, no question marks, and one part only question marks. So we are going to build a model with data with no question marks. So we are going to learn a pattern, and we are going to use that pattern to determine the values for question marks. So this is more advanced. And of course, there are 5 and 6 and other methods to handle missing values. Okay, so the first thing you might think of is delete, but don't delete. If you have, like, for example, 1%, 2%, 3% of missing values, just go ahead and take it out. You don't have to sit to waste your time. But if you have 50% or 20%, 60%, delete is not an option. Impute is not an option if that is the case. So you got to keep them as is and just simply replace them, give them a meaningful name. Any questions, concerns about these missing values?
Good for me.
Okay, so we got that. And
brother, can you please repeat number 3 one more time?
Number 3 is called impute. Number 3 is we are going to keep everything. Just keep your missing values, and we are going to use a few machine learning techniques, algorithms, that they don't really care if you have a missing values in your data. They are going to handle missing values proficiently. And some of the algorithms that does that: decision tree, random forest, bagging, boosting, adder boost, etc. They do handle missing values and outliers efficiently. Either you have them or you don't. If you have missing values, you have outliers. This list of machine learning, they really don't care. So missing values or outliers wouldn't affect the performance of this type of machine learning. Clear?
Makes sense. Thank you.
You're welcome. Okay, and now we have here. So number one, we need to. I think I'm using a different data set. I'm using a different data set. So now let's take a look into what needs to be kept. We are going to remove all the features that we learned about yesterday. Let's do that. So we are going to come up. Let's first bring out all the features. So now we are going to come up with to delete. So now tell me which features that we should delete using the prior knowledge. Month as a customer, we are going to remove the policy. Number is an ID, right? If you don't agree, stop me. We are going to remove a band date. It's a date. We don't need it. Policy state, policy CSL, policy deductible, policy annual premium, umbrella. We are going to remove insured zip, insured sex, insured education level, occupation, hobbies, relations, capital gain, capital loss, incident date. We need to remove that. Incident date, incident collision type, incident severity, authority contacted, incident state, incident city, locations. We are going to remove that. Locations, number of vehicles involved, property damage, bodily injuries, witness, policy report, available total claims, injury claims, property, or make, or model, or year, and target variable. So you got 1, 2, 3, 4, 5, and 6. We got 6 elements. So now I need your help, guys, to determine the features that we determined to remove using correlation analysis. Do you guys remember them? One of them is age.
Incident location.
Incident hours of the day. And we got property damage. No, we got the claims. Total claims, injury, property. I think we are going to keep vehicle claims. So this all needs to be removed. And
how about policy deductible?
No, we have to keep it. Okay, so these features here, they were determined. We determined them. We found them using prior knowledge, number one, and we used also the correlation analysis. Okay, one more thing that I want you to be aware of. So when we are using the statistical analysis, describe. So please pay very, very close attention to these numbers. Okay, so we got here, we got the month as a customer. And we get age. And we know the month as a customer and the age, they are highly correlated. Simply means we are going to keep only one of them. Which one? We are going to keep the one with the highest correlation with the target variable. Okay, simply means we are going to keep month as a customer. But look into this month as a customer, we got the minimum, it's 0, and the maximum is 479. We got the minimum and the maximum. And we got a problem here. You really got a serious problem. And if you are not paying attention to your statistical analysis, you might be off later on. So you've been a customer with us. And I know you've been a customer with us, but why does it show 0? The minimum month that we have is 0. The maximum is 479. What is the problem here?
It's just the first month not completed yet.
Then what do we need to do?
Eesh.
Convert it to days or weeks.
Yes, that's a good. Yeah, good point. What else? So we need to go one level of granularity. You know, the month is not, because you could be insured with us for 27 days, and because you have not completed the month, it's going to show 0, and the 0 is not going to help me. So we could go, we could calculate this by weeks, but I think we don't need. We need to transform this into a day. So it's going to be day as a customer. Otherwise, this 0 is going to be an outlier. It's going to be a serious outlier, and you have to delete. You have to do something to it. So pay attention to your statistical analysis. It's really good. It's really always advisable to go through these numbers. Try to make sure they do make sense statistically. Especially the minimum, maximum, age is good. And so we could debate with the business or with the team which to keep. If it does require, if month as a customer require a lot of work, or if we don't have a days, I would simply eliminate month as a customer and keep the age. I know there is we are losing certain influence, but it does save us time in terms of data preparation. So let's keep age. So we are going to keep age, and we are going to remove. Normally, we should remove month as a customer, but we have a problem with that. So we are going to replace month as a customer. Yeah, we are going to replace month as a customer with the age. So these are the features we are going to delete. Now we are going to override our data. Our insurance is what is equal to our insurance, but we are going to drop the list, which is to delete, and we have to specify what to delete. Are we deleting rows or columns? So axis equals 0 means deleting rows. Axis equal 1 means deleting columns. Okay, I'm going to run this, and it's going to throw an error. So, yeah, to delete. Yeah, we make a list number 1. Okay, and now we are going to override our existing data with the same data, but we are dropping everything in this list. We are dropping all of this, and I'm telling it drop axis equals 0 means drop rows, and I'm giving this problem. What do you think is the problem? So x is equal 0 is rows, and x is equal 1 is columns. So are these rows or columns?
Should be column.
So what would be the value for x's?
1.
Yes, sir. I did this in purpose because I want you guys to learn how to code. So we created a list of columns to delete, and we are telling it, go ahead and delete these columns. So x is equal 1 is columns, x is equal 0 is rows. So now it's going to work. And now let's do the shape. And we have 28. So we started with 29 and 1,000 claims and 39 features. And now we end up having 1,000 claims and 28 only. So 11 features have already determined to be removed using the prior knowledge, and also using the prior knowledge, and also using the correlation analysis. Okay, good. So now we have removed some features that we don't need, but still we are having, and we took care of the question marks. And by the way, there is a lot of problems with this data, but because this is a very short program, I have to shortcut everything and just move to the point. Otherwise, it's going to take at least 12 hours, 3 sessions or 4 sessions of 3 hours to complete all about this data. Unfortunately, this is a very free program, short program, so I don't have time to. We cannot go over everything. Okay, so now we have this data. We removed some features that we don't need using correlation analysis and priority knowledge. We took care of the question marks, and now we have to take care of the categorical data. And for categorical data, you have to be careful. Now, why is that? Because categorical data could be, you could use a wrong transformation method. You could use a wrong transformation method, and I will explain that shortly. So we got this data here, and we have to transform them into numeric. But before we do that, let's assume that we have a small data set that looks like this. Got a small data set. Okay. And we got, let's say we got gender. Yeah, we got gender. Or J for short, because I don't have space. And we got here education level. Okay, we got gender and we got education level. Okay, and we got here F, we got F, we got M, we got F, we got F, we got M, we got M in there, and we got M. For education level, at least we do have associate degree. We got master, we got high school, we got PhD, we got BS, bachelor, we got MS, we got a PhD, and we got a bachelor's. So we got, this is a real data. Let's assume this is a real data. Okay, we got gender, we got education level, and so how many, this is are called levels. How many levels that we have for gender?
2,
You got 2. What are they?
male and female.
Female and male. And how many levels? So they are called levels, and also they are called cardinals. How many levels that we have for education level?
5.
So we got 5. Okay, we got 1, 2, 3, 4, and 5. And you could have millions. We have 6 million records. 6 million records. So this goes all the way to 6 million. So now we need to transform this. We need to transform this gender and education level into numeric. They are categorical, all right? And why do we need? You might ask, why do we need to transform them into numeric? Because the machine learning, which is simply a mathematical, it's all math. They are designed, most of them, they are designed to handle numeric data. Some of them, they are designed to handle numeric and categorical. Some of them, they are designed to handle numerical, purely numerical. The moment you feed categorical data into them, they are going to yell at you. They are going to throw a bunch of errors. So what do we need to do with gender? We need to transform it into numeric, into values. So can anyone please help us to transform, can you please transform this to numeric? Anyone?
PhD is the 5.
Say again?
PhD 5, number 5.
What do you mean, brother, by number 5?
Rank.
No. Can anyone? What we could do? We have to replace.
Zeros and ones.
No, we could replace this male and female with 0 and 1, or 2 and 3, or 1 and 2. Can anyone try to transform this gender from categorical to numerical?
Can we apply any number more? Like if I say female is 2 and male 3, so it will be 2, 2, 3, 2, 2, 3, 3, 3. That will be the case, given the fact that 1 and 0 could be discriminatory based on what we discussed before. Is that right?
Yes, ma'am. Let's do 2, 2, and 3. We got 2, 2, 3, 2, 2, 3, 3, and 3. So this method is called mapping. And how about this, the other one?
Is the ranking the education level? Like high school is 1, associated 2.
Yeah, hold on, please hold on, brother. Okay, say again. Association is what?
Or we can do with the level of the education, like how many years we can done this. The high school at least like 12, and bachelor is 16.
Yeah, you said 12.
Associate is like.
Okay, let's give me numbers. Let's give me numbers.
High
We
school.
we can use like 0 for high school, 1 for an associate degree,
Yeah, we can
3
do
for
that,
a
yeah.
bachelor's.
Let's do this. High school. Where is high school? Here is going to be 1.
One.
Okay.
Associate.
2.
Yeah, we could do the years too. Yeah, we could do the years too. Bachelor is going to be 3. Yeah, is going to be 3. And master's.
So we have BD and BS. So BD and BS both are the bachelors, right?
Yeah, it's BS. I'm sorry. This is a BS. 3 and 3.
3 and 3.
And we got PhD 5. We
Yes.
got 4.
And six.
And we got 5.
Yes.
Okay, we talked about this in the previous one of the previous sessions.
I have a quick question.
Yes.
On the gender, why don't we ever use like two different numbers, one for missing and one for other? We can have invalid and we can have missing.
We don't have a missing now.
Okay.
Yeah, there is no
But
missing.
what if we have something that's invalid? Why don't we use that too?
Like what?
Like you have 2 and 3, I will use 4 for invalid. Anything else that doesn't match the 2 and 3, then it will become kind of like an else statement.
No, because we have only how many levels that we have?
Okay, so you are assuming your data is very clean already.
No, I'm asking you for this example, how many levels that we have?
You have male and female right now.
So how many levels?
2.
2.
That's it. If you have
But
3, you could do
how
that.
do you know your data is always clean?
I'm talking about this given data set.
Oh, I see.
In the
I
real
see.
life, that you need to visualize it. In the real life, you need to visualize it. You are going to find do something like this. And you are going to see male and female, or you could do the value count. Value count. If you were to do the value count for gender, yeah, we are going to do value count for. I think it's called insure 6. Here we go. Yeah, gotta do value count.
I see. So you verify that first.
Yeah, yes. We
Got
got
it.
53% female, and for we know. Yes, you're right. Sometimes you are gonna see something like this, and it's very common, especially if this is a survey that you send to someone to fill out. You are gonna see male. Then sometimes you are gonna see the whole word female. You are gonna see male. You are gonna see the whole word, the word male. So now, how many levels do we have?
You still have 2 because you have to clean your
No,
data.
it's not 2 anymore. It's not 2 anymore.
Yeah, but you need to clean your data now.
Yes. But now my question is, how many levels do we have now?
4.
Got 4. How many we are supposed to have?
2.
Then we need to clean it. Okay, so we need to transform all the females to, or the F to females, or all females to F, and the same applies to, at the end, we need to have only 2. Unless there is a category that you know about, I don't want to talk about it.
Hi, Miss Company, Ro from Geico. I spoke with you a few moments ago. Are you going to need a rental?
So yes, so now we got 4, but we're supposed to have only 2. So we need to clean. Number 1, we need to clean it first, then transform it. So transformation comes after cleanup. But for this gender, there is something wrong with this. Now we got 2, 2, 3, 3. A female would come to you and say, "Why did you give me 2, and why you gave yourself a 3?" And they are right. And remember that machine learning is all math behind the scene. And of course, since it's math, 2 is less than 3. 3 is higher than 2. In other words, the model is going to concentrate on number 3 or rather than number 2. the model is going to be now biased towards females rather than giving them the equal chance. So what's wrong with this transformation? We are in the data, we have an ordinal. I'm sorry, this is nominal data. Yeah, we have nominal data, and we are using, yeah, we have nominal data. Yeah, this is nominal, and we are transforming it to ordinal. This is wrong. This is very wrong. So mapping is not going to be an option because the data that we have is not ordinal, it's a nominal. Whereas in the education level, we have an ordinal. We know BS is less than master's, master is less than PhD, associate is less than bachelor's. So PhD is better, comes first. If you have PhD, you are better than master's. If you have master's, you are better than a bachelor. If you have a bachelor, you are better than high school, and then associate than the high school. So we have some ordering in there. We have some sequence, and transforming them into 0, 1, 2, 3 is good to go. So before you transform your data, number one, you need to clear it up. Number two, you need to know the type of the data that you have. Otherwise, you are going to have a problems. You might end up using a wrong transformation method, and you might end up creating some bias within your data.
Momo, really quick before we move from that page. So why is the female wrong when you translate it into numbers? You say that it goes from nominal to ordinal. So what is that correct or is not? I didn't get that properly.
We were to keep the 2 and 3. The model is going to think 3 is better than 2.
Okay.
So the model is going to be biased towards 3. The model is going to give a better concentration to the male versus female.
Okay, I understand that, but how then we can, given the fact that machine learning is mathematical, we have to assign numbers, and the numbers are continuous, and they are increasing or decreasing. So there is no, how we're gonna actually then transport that data so it can be properly read or I don't know, whatever we're gonna do with that, analyze.
So this method is called mapping. This method we just used called mapping. We map a female to a number without any scientific method. We map randomly. We map male to a random number. It's going to be 0 or 1. So mapping is not a good option. Of course, there are other options. There are other options. One of them is called encoding categorical data, labeling encoding, label binarizer encoding, one-hot encoding, and dummy variable encoding. There are many methods. So now let's do a dummy mod encoding.
I have a question here, brother.
Sure.
When you talk about the educational level, what if the sample population that we have is not equally distributed among all the levels? Would it affect, and how would it impact the analyses?
Still, I mean, I'm not talking about this. I'm talking about is your data ordered, your data ordinal. That's it.
Nice.
I don't care about this. The distribution is something else. Is another problem that you need to worry about.
Oh, okay.
But right now, what we care about is the overview. We have ordinal data, then we can simply transform it into orders, into sequence numbers. You have nominal, you cannot do that. Okay.
No, but it seems to me that everything in math is discriminatory. So the fact that I'm assigning numbers to the education level can be discriminatory as well, because I could give preference to someone in the insurance industry, in the insurance business, that it has a higher level of education, a PhD or a master's, instead of just a high school. So how do you actually eliminate that problem,
So
given
let me
the
ask
fact
you a
that it's a
question.
mathematical model?
Yeah, let me ask you a question. If you have a PhD, are you better than someone who has a master's? Yes or no?
No, in levels, professionally speaking, yeah, you have a higher level of education,
That's it.
more
That is the
expertise,
answer to your
perhaps.
question. So we are going to give you, since you are higher than MS, than masters, you are going to give you a higher number than MS. So actually, we are not discriminating here. This is what we have in the data. Simply, we are giving numbers instead of using the names. But
Yeah.
in terms of gender, are you better than me? This is you, female, and this is me. Am I better than you?
No, I mean, technically speaking, no, but we don't know exactly.
No, I'm
I
talking
mean,
about
there
human
are
rights.
areas of
So just
women and men
let's
are
talk
quite
about
different.
human rights.
Yeah.
Let's say that you know we apply for the same position in a company. Would you be okay if they choose me and they didn't choose you because I'm male and you are female?
No, that wouldn't be appropriate or
So
correct.
then you cannot give me a 2. I cannot give you a 3. You cannot give me a 3. I cannot give you a 2. Why is that? Because you and I, we are not, we don't have any ordering sequence in here. We are equal.
Yeah.
I cannot give you 2. I cannot give myself a 1. I cannot give you a 0, give myself a 1. I cannot give myself a 0, give you a 1.
So what is the best method to
That is what I'm trying to
eliminate
explain here.
Because a race will pose the same question: Hispanic and American, Caucasian, this and that will have the same problem as well.
That is what I'm trying to explain here if you were patient.
Okay.
So now we know the mapping is not going to work. So now we are going to try one method. It's called dummy variables. It's called dummy variables. So this dummy variables, what it does is for every single level. How many levels that we have here again? We got 2, right? So for every single level, the dummy variable is going to create a column. So let's do that. So we are going to use the column name, which is G underscore, then the name of the level underscore F. Then it's going to create another one, which is G underscore M. And if you have 3, it is going to be a G underscore 3. Now, okay. So this dummy model is going to represent the gender using 0 or 1. So the first one, is it male or female?
Female.
Female. So we are going to give it a 1, and we are going to give it gender a 0.
0.
The second one?
Same. 1, 0.
This one?
0, 1.
2.
Now it's going to be 1 and it's going to be 0, not 2. It's going to be 0. It's not female, but it's a male. This one, it's a female, it's a female, not a male. It's a female, not a male. It's a male, not a female. I'm sorry, it's not a female, it's a male. It's a female, not a male. It's a female, not a male. It's not a female, it's a male.
0, 1, 0, 1.
Here we go. But there is a problem with this one.
It's a duplication in there.
Yes, so, and let me ask Carolina. Sorry if I'm mispronouncing
Yeah,
your name.
Carolina, it's fine, Mo. It's the
Carolina.
same thing.
Yeah,
It's the same thing. The only thing is that you're flipping.
Just be patient.
Yes. Okay.
If I asked you, are you male or female? What would be your answer?
I'm a female.
Okay, so why? Can you tell me? Can you say I am a female? I am not a male.
Yes, I am a female. I am not a male, from what I know. Yes.
But what is wrong with this answer?
It's like I'm negating one thing, and it's the same thing. It's just flipping it around.
Just stay with me. Stay with me, Carolina.
Yeah.
Stay with me, please. I asked you, are you male or female? And you said, I am a female. I am not a male. My question is, what's wrong with your answer?
That I'm reaffirming the same thing in two sentences. I'm saying I'm a female.
You are repeating. In other words, you are repeating yourself twice.
Yes.
Is that necessarily?
No, that is not efficient.
So you are giving me information twice. You are duplicating the information, right?
Yes.
So if you say I am not a male, what does it mean?
That I'm a female.
If you say I am a female, what does it mean?
That I am not a male.
That's it. So that simply means you have to eliminate one of them. So you could, if you tell me, you have to eliminate either I am not a male or I am a female. So which one do you want to eliminate?
I want to eliminate that I am not a male, because it doesn't, if I say I'm a female, that's, it's more efficient. It is more accurate than just negating the other side of the thing to say.
Both of them, they are accurate.
Yeah, but they're accurate. But
no, I don't want to go into the details. But if you say I am not a male, it means to everybody in the room that you are a female, right? If you say I am a female, it means to everybody in the room that you are a female. There is no need for repetition. If you're repeating, so which one you need to remove, it does not really matter, because at the end you are going to provide the same information. If you are telling us you are female, you are eliminating I am not a male.
Yeah.
If you are telling us
what I'm seeing
male,
here,
you are eliminating the female. So that simply means you can eliminate one of them. So which one to eliminate here?
If I can really quick, in comparison to the mapping, so what we're doing, because we cannot use the mapping because of the discriminatory nature of it. This one is the very same thing, but we are not assigning zeros and one, 0 to a female and 1 to a male. We are actually flipping, because we are putting different premises, or two premises, so we're actually flipping the values. We're saying that a male is 0 and that a female is 1. But it's the same thing, because that can be understood in the data and can be discriminatory.
It's not the same thing. I will tell you why. So in the first exercise, we are as a human, we are choosing the numbers. So we are discriminating between male and female. We are going to give, if you were to give you a 0 and 1, this is discrimination. For this one, there is no discrimination. This is the true values determined mathematically. So zeros and ones, they are the same, yes, but the way we determine the zeros and ones are totally different. The first one
but
is
let me
100%.
ask you something. If someone knows what type of or transformation method did we use, we didn't use mapping, but we use dummy variables, so they can infer from there that that the value of female and male is kind of flipped. That the actual male is a 0 and the female is a 1.
No, ma'am. So before you determine the type of transformation to use, number one, you need to determine what type of categorical data that you have. If your data is nominal, you cannot use the mapping, because you are going to create some discriminative problems, some legal issues. So we need to use one-hot encoding or the dummy variables, just as we saw here. If your data is ordinal, mapping is a good a good option. Okay, so now we are duplicating ourselves, so we need to eliminate one and keep one. Which one to eliminate? It doesn't really matter. So I could eliminate, if we were to eliminate this animal, J underscore F, we are still going to get the same information. If we were to eliminate this, we are still going to get the same information. She is a female, she is female, she is not female. So simply means she is something else rather than the female, and we have only two levels. That simply means she is a male. So the point I'm trying to make out of this short exercise is, as data scientists, we have to transform our categorical data into numeric. But before we do that, we have to determine what type of categorical data that we have. Don't simply jump in and apply your transformation just because you feel like doing this method versus that one method. Okay, let's continue. So we are going to use the dummy variable. We are going to make a copy of our data, and we are going to find out all the categorical values. So these are the categorical features. And now we are going to do a dummy variable. So these are the features that we need to dummy. And now we are going to apply, we are going to import get dummies. So we have a list. To apply dummies. So anything, all the column names that they are not numeric should be dummy. So we have to dummy. To dummy simply, to dummy is a feature, or is a variable that contains all non-numeric features. And we are going to use this to dummy to transform into numeric, and we have to drop one. We cannot keep both of them. So if you have, for example, a column with 20 levels, how many features we are going to create using
90.
dummy variables?
20.
20 minus 1.
20 minus 1. And it's called n minus 1.
Okay.
So if you have two, how many? If we have only two?
1.
No, in theory, we are going to create two, but 2 minus 1 is going to be 1, right? If we got 150, we are going to create 150 minus 1.
And why is that? Because Python assumed from 0. What is the reason for that? I'm a little bit lost.
The reason is you are duplicating the information, and we don't need, when the model sees duplicates of information, that would cause a bias problem later for the modeling.
Okay.
Okay, so we are going to tell it drop one. Just take out the first. And here we go. And now let's take a look into, so now we got all zeros and ones. Beautiful. Got all zeros and ones. And now we are going to use math to determine the hidden mathematical relationships between these features. Now let's take a look into how many, the shape. Of course, we got, this is the original data, and now this is the data we are going to shape. Okay, so we started with a small data set with 1,000 feature, 1,000 column, 1,000 records, and 39 features. Then we applied the prior knowledge correlation analysis. We reduced the 39 features to 28. And now we, within this 28, we have few features that they are categorical. We transformed them into numeric, and we got 134. This is good or bad?
Good.
Anyone else?
It's bad.
Yeah, it's very bad. Yes,
Why?
because that we have too many.
Okay.
So we started with 39. We were not happy with 39, right? We were not happy with 39 because a lot of features should be eliminated, and we dropped it to 28 scientifically. We were very happy, but unfortunately, within this 28, we got some categorical that we need to transform, and when we transform them, we end up having 134 features.
Okay, so expand it more instead of contracting it and make it more concise. Okay, I understand.
So now the question is, what do we need to do?
Reduce column.
What do we need? Yes, we need to reduce this dimensionality one more time. What do we need to do? Can we use prior knowledge?
Yes, we can
Yes.
eliminate other columns.
No, ma'am, we cannot use it anymore. It's done.
It's done. Okay.
We use correlation analysis? No, we cannot use correlation analysis because the conditions for correlation analysis, there are 4 conditions, and we talked about them yesterday. Number 1, they have to be pairs. Number 2, they have to be numeric. So the values have to be pairs. They have to be numeric. Number 3, they have to be linear. And number 4, which is very important, they have to be real. Are these real numbers? Are these...
Brother, can we collapse the categories?
Yeah, my very simple question. Are these real numbers? Yes or no?
No, from my
No.
perspective.
Why?
They're binary.
No, that isn't the answer. Anyone? Are these real numbers?
No, these are integers.
No, are they real? True.
No, because they're dummy variables, right?
Yes, ma'am. Thank you. They are not real. I'm not talking about real or integers. So they are not real because they are transforming values. The actual values were sleeping, reading, boarding games. These are the true number values. But we transformed them into dummies. We got zeros and ones. So we cannot use correlation analysis anymore. You still can use it, but whatever value you are getting does not represent the true correlation. So we cannot use prior knowledge to reduce the dimensionality. We cannot use correlation analysis anymore. We have to use something else. And of course, there are other techniques we are going to use later. And we are going to learn that. Okay, and so that's it for now. We are going to save this. Yeah, we are going to save this into version number 3. Version number 1, we got 1,039. Version number 2, we got 1,000 but 28, and we replaced the question marks. Version number 3, we got 1,000 and 135. This is our numeric. One thing that you need to worry about is look into the values. This is very important again. What do you think about these values? You got, for example, umbrella limit. We got 0, 500,000. We got vehicle number. We got 11311. Body injured. We got 10210. We got deductible 1,000, 2,000, 3,000, 1,000. What do you think about these values? They are different, right? In range. Range-wise, they are different, right? You guys agree?
Yes.
Yes.
So again, remember, machine learning is all math. If we were to apply machine learning to this data, what do you think is going to happen? The model is going to think that 50, 100,000 is better than 0, 3 is better than 1, 2 is better than 0, 1 is better than 0, 2,000 is better than 1,000, 600,000 is better than 500,000. So in other words, the model is going to be biased.
Bias, yeah.
Well, I have a question with that. It's more like a philosophical type of question, because that is exactly what mathematics is in a way, is to measure. So if I have a salary of $1 or $100,000, I mean, that is math. I don't get, you know what I'm trying to get at is, so I understand this is information and numbers, which is mathematical numbers, which are giving us a range of 1 to 500, for example, being 500,000 a greater or better number as for the machine interpretation. But that is the nature of mathematics, isn't it? In a way, to measure things and give us an idea of.
Yeah, and we have to fix it.
Okay.
We cannot use the data as is. There is another one last method, could be, that is called normalization. It's called standardization. It's also called, we could do standardization, we could do normalization, we could simply do scaling. So we need to put this scaling. Now all of these three, they could scale your data. Yeah, they are going to put your data between 0 and 1, or -1 and 1. Another one, -3 and 3. So we are going to put a vehicle between 0 and 1, witness between 0 and 1, body injured between 0 and 1, umbrella limit between 0 and 1. We have to normalize it, to squeeze it, to squeeze everything, all the elements of data. We are going to put them between 0 and 1. And the model then is going to treat them with equal opportunity, with equal importance. So we have to scale, and we are going to learn that later in the machine learning. So now we got the data. It's ready. We got the data is ready, and now let's take a look into. So now we have dummy variables. We don't have real values. And how do we need to invert back to reality? We really don't care. So what we are trying to do here, we are trying to understand the true mathematical relationships between all these features. And once we understand that, we are going to apply it to you, Carolina, tomorrow. If tomorrow you called me to report a claim, I am going to simply collect the data from you, and I am going to apply the same technique, the same transformation, the same data preparation that I did on yesterday's data. I'm going to apply it to your data, and I am going to apply also what I have learned from historical data. I'm going to apply it on your transformed data, and I'm going to get a score. And based on that score, I'm going to determine if you are lying to us or if you are telling the truth. So we don't care about data anymore. We care about the hidden mathematical characteristic behavior of your data. That is what we're looking for.
So if a model in reality predict what we're looking to do, it can be applied to predict something. Is that fair to say?
Yes, to predict you, let's say that you call me tomorrow. You are going to call me tomorrow. You are my client. You've been insured for the last 6 years, and you called me tomorrow to report a claim. Can I determine if you are telling the truth or if you are lying? I can do that. I can guess 50-50. I can have a better guessing. But how about if I want to determine the true reality or an approximation reality? It's very close. Is number one, we are going to build a system that learns from what happened in the last 6 years. So we are going to build, it's called machine learning. It's all math, and we don't worry about it. We don't care about it, but we are going to use it. We are going to use the applied part of it. We are going to use that model to find the mathematical relationships in the 6 years of the historical data. So we are going to learn a function, and we are going to apply that to your case. After, of course, we bring your data to be similar to the data that we use to build a model from historical data. And now, instead of guessing 50-50, I could have a better prediction, probably 90-10. 90, you are lying. 10%, I could be wrong. You could be telling the truth. 90%, you are telling the truth. 10%, you could be lying. So before it was 50-50. 50, you could be fraudulent. 50%, you could be telling the truth, right? When you first called, without doing anything, I could guess. If your spouse is pregnant, you could guess in the first month she's 50% male, 50% female. You could guess. But now we want more accurate result. Then we have to do blood tests. We have to do a lot of tests, and we have to wait. Then that 50% will go to 60-40, then 70-30, then 80-20, then 100% zero. 100% is a girl, 0% is a boy. It's the same concept applies to your case if you were to call me. But before I do that on your case, I have to learn something from the historical data.
Yeah, I understand. I think, yeah, so it's just a simple, that's why we're trying to condense everything, because we're trying to get to that target variable. In this case, it is a fraud or not.
Yes, and to get there, we are not trying to get in. What we are trying to determine, number one, is what drives, what has driven, what has caused a case in the past to be legitimate or to be fraudulent. Mathematically, can you find out if we discover what has caused our 70%? Historical data, we got 70% of claims that are legitimate. Yeah, we got 70%. Yeah, 75% of, now mathematically we need to find what has caused 75% of our historical data of 1,000 claims that we processed in the past mathematically, and what has caused 25% to be fraudulent. If we find out these mathematical hidden relationships, I can predict your case tomorrow with a good accuracy. And to find out those mathematical hidden relationships, we need to bring the data into a mathematically acceptable format. So this is not a mathematical acceptable format because we have categorical, we have question marks, we have so many things. So now this is a mathematical acceptable format, but still we got one more issue that we have larger numbers and small numbers, and the model is going to be biased towards larger numbers. So we need to squeeze everything into one range, and with that one range, the model is going to treat every element equally. Other than that, the model is going to think the 600,000 is better than everything else. Yeah. So concentration is going to be given to umbrella limit, and that is going to be biased, and we don't want to do that. So to make the story short, so to predict your case tomorrow, we need to learn from what happened yesterday, and to learn mathematically, and to learn what happened yesterday, we need to shape that data to make it mathematically sound. Does it make sense?
Yes, Mo. So basically, machine learning, what it's gonna give us like.
Carolina, please hold on. Does it make
Yeah.
sense? Yes or no? Before we
No, it does make sense. I do understand. Thank you so
That's it.
much. But of course, every understanding creates more questions because I am a current client. So you're going to predict if I am being fraudulent in my claims or not, based on being an existing client. What about for future clients? Does this machine learning model and time framework that is providing me can predict if a new client that this insurance company or your insurance company is going to take is more likely to commit fraud or not? That will work that way too, given the fact that machine learning is providing me that sort of framework or some variables to predict that.
when you were preparing your data, you already have in mind the objectives. Okay, so preparing the data has to go in line with what you're trying to do. In our case, we are trying to predict if a claim is fraudulent or legitimate. If our case is to determine if a client, not a claim, a client will commit a fraud or will tell the truth, then we could have prepared the data in a different way. So before you're preparing your data, you have to, number one, understand what you are trying to do. And in our case, the concentration is the entity. If you guys remember in one of the sessions that we covered, number one, you need to understand the as-is state, to-be state, the success of transition, and the unit of analysis or the entity, that is very important, and the target variable.
Can you have two target or more target variables like
It's
existing
one at a time.
clients?
No, one at a time. Not do
Okay.
two targets variables, one at a time.
All right. Okay.
So in our case, we are trying to predict if your case, not you, I don't care about you, but your case, you just called in to report, is that case legitimate or fraudulent? That is so the concentration is not you, is your case. If we want to concentrate on you, then of course we have to redesign the entire process.
Mm-hmm. Understood. Thank you so much. Thank you.
You're welcome. So now we got the data. It's ready, and again,
Brother Mohammed.
Yes, sir.
Yeah, regarding historical data, for our analysis, is it better to use the whole historical data or just few years?
Well, that is a question that you need to discuss with the business, and I will tell you why. In terms of can we use all the historical data? Probably no. Why is that? It could be too much. It could be too much data. So let's imagine that you have 20 years of data. Can you use all of the 20 years of data? Yes or no. It totally depends on the business. I'll give you an example. Let's say that you are working for Apple. Okay, and you got 20 years of data. Okay, we got this is 2022, and we got 2000. Okay, got iPhone in there. Then 2006 start. There we go. So you got 20 years. Do you really need to use all 20 years, or you are going to concentrate on the part that makes sense to you?
Yeah.
You don't need to go because here we are not doing any progress. The progress starts with 2006. We really don't need to go back all the 20 years. So again, do we need to use all historical data? It depends on many factors. Number one, how long do you want to go back? And another example, let's say that you are working for a bank, and your job is to approve or deny a loan application. I came to you I submitted my physically. I submitted my application, and I needed some money to go back to school to pay for my school student loan. Okay, and you have a data since 2000. So let's say that 2000, I was making 50,000 per annum. 2006, I made 70. 2010, I made 10,000. I lost my job, for example. 2014, I made 110. 2016, I lost my job again. I'm making only 10. And 2020, I made 130. Then 2022, I made 170. How long do you think you should go in my history to determine if I need or to approve or deny my student loan? If you go back all the way to the end, you are not going to approve my loan, right? Because I got some zeros in there, and the average, it could be 60,000. But if you go only 2 years or up to 2000, then you are going to approve my loan. So that is a business rule. How far you need to go, that's something that you determine with the business. And if this is not the case, and you have you have 20 years of data, of course, that is 20 years of data might not be able to process it using your given infrastructure. I cannot process 200 million records using my laptop. It's going to crash. Khalid, are you clear?
Yes, Brother Mohammed, thank you.
You're welcome. Okay, folks, so I believe we are going to stop here for now. But so again, we only covered a small percentage of data preparation, unfortunately. So we talked about business understanding. We talked about data understanding, and we talked about few of data preparation. Of course, this is not an exhaustive list of what needs to be done, but most of the transformation methods are listed here. You have to deal with missing values, outliers, cardinality. You need to convert categorical data into numeric. Of course, before you do that, you need to know what type of categorical data do you have. Is it nominal or ordinal? You transform your data. You normalize, standardize, factorize, binarize, standardize. You apply correlation analysis, which we did. We aggregate, bin, you decompose. If you use time series analysis, you extract some features using feature selections, which we already know. In the feature selections, we use the prior knowledge and we use the correlation. But we still have 135 features, so we need to have more. We need to have some advanced techniques to further down reduce the dimensionality, and we are going to learn next week. And now we have a better version. We started with a raw data, which was 39 features and 1,000 rows, and we ended up with version number 2 with 1,028, and now version number 3 is going to be 1,134. And of course, we are going to do a version number 4, and after that, that is version number 4 or 5, which we are going to use for modeling, and the modeling is going to be the topic for next week. So,
no, I'm gonna ask you a favor. You could really quick for me. I understand theoretically and the lectures and the sequences, but when I go to Python, I try to recreate all these things. I cannot pass the third line, and I don't know what is my problem. If you can just help me to visualize really quick, how can I make this happen?
Yeah, can you please schedule a one-to-one session? I'll be more than happy to help you.
Thank you so much. I appreciate it.
No problem. I already shared with you guys my calendar. Please go ahead and schedule a one-to-one session. I will be more than happy to assist you. Okay. Unfortunately, I gotta go because I have something else, and also I'm going to be available tonight. If you are going to be available after Tarawih, I will be more than happy to assist you. And don't forget,
Thank you.
Brother Shahid is here. He's a TA. Just talk to him. Also, he might help you.
Yeah, please send me a message on WhatsApp or whatever you prefer, and then I'll get back to you. We can set up a schedule to meet.
Yeah, what is your name again? I'm sorry, so I can look you up in WhatsApp.
Shahid, that's my name. Shahid Zahir.
Yeah, there is just a lot of messages in there, so I kind of get lost slightly with the amount of.
Okay, send directly to me, then instead of sending it to the group.
All right, understood. Thank you so much.
Thank you.
Okay, folks, that's it for today. I'll see you guys next weekend. Until then, you guys have a great evening, great rest of the week. And bye, everybody. Assalamu alaikum wa rahmatullah.
Thank you, Mo.
Thank you, brother.